the first derivative. The function, of course, is always first, then the first derivative, and now we're moving on to the second derivative. Once we have our findings, we come back here to the table to put them in. Okay, so I'm not going to differentiate this. I'm going to differentiate this to find the second derivative. So 36t squared minus 48t. Always defined, so g double prime of t is 0, and I have 36t squared minus 48t equals 0. I can divide by 6 at least, right? 6t squared. Okay, and I will also divide by 2. So this is 3t squared minus 4t equals 0. And now I can factor out t. I can never divide by variables unless I know they can never be 0. So we have two options here. T could be 0 and t could be 4/3. And as expected, of course, it will be very crowded on that side of 0. Okay, in my table. Okay, so 0 for the second derivative at 0, and 4/3, which is 1.3, so it's on this side, of course. Everything had to be right here on 1 squared inch. Fine. At this point, I study the sign of the second derivative. So let's take a look. So where is my derivative? Right here. Okay, so the second derivative, g of t, g double prime of t, is, we factored out 12, so 12t. And this was, what was it? 3, yes, 3 minus 4, 3t minus 4. Okay. Perfect. So I have no choice. I have to analyze both, right? Both factors. T can be positive or negative. 3t minus 4 can be positive or negative. But just remember, just imagine, if you imagine graphing this function, crossing at 0 at 4/3, you will realize that outside is positive and inside is negative, or plug in numbers. So in this function, if I plug in -10, I guarantee you I will get a positive number. So -10, this will be more than -30, and this is negative. Negative times negative will be positive. But if I plug in 1, this is positive, but this will be negative. So it will be negative. And the same thing on the other side. So we have the sign. So positive, negative, positive. I have to plug in this number to get the y value here, where the 0 is, right here. There is no need here because I already have it. But I have to plug in 4/3. So let's plug in 4/3. Okay, here it is. 4/3, I already did. This is 4/3, 2.5. So this here is 2.5. At this point, I analyze what this tells me. Every time the second derivative is positive, we know the function holds water, concave upward. If the second derivative is negative, the function does not, concave downward, and of course upward. This is the symbol for coming from the sign of the second derivative. Now, at this point, the second derivative changes sign. What kind of point is 0, 12?
Inflection point.
Excellent. At the point 4/3, 2.5, the second derivative changes sign from negative to positive. What kind of point is 4/3, 2.5? inflection point. Do you think there is a need for me to redo the table, or is it clear enough? Why I would have redone the table is because they're so close here. I should have just spread them a little bit further. But if it's clear, I will not have to do it again. Is this okay?
I personally find it fine.
Thank you. Well, the thing is that I'm using these markers and I can't go back. Okay, nothing else matters. This is why this table is so powerful. Nothing else matters but the table to graph the function. No other information is important. I'm not going to throw anything away. I'm just making a point. I don't want to see anything else. I don't care about anything else. All the information is summarized for me in the table. So the table now will guide me to graph the function. So 0, 12 is the y-intercept. Then I have to plot 4/3, 2.5. It's not easy, 1.3, and then 1.5 and 2 and 2.4. So I'm going to try to use a wider unit. So I'm going to say that this is 1, and this is 2, and this is 3. Now, of course, if I do this, then 0, 12 will be out of my page. So I'm going to say 4 and 4 and 4. Okay? Or 5, or whatever you want to put in there. Maybe 5 is better. I don't know. It doesn't matter to me. So this will be the y-intercept. Then 4/3, 2.5. So if this is 1.5 and that is at 0, then 1.3 I'm going to say is here, and 2.5 somewhere here. So this point is 1.3, 2.5. This point is 1.5, 0. This point is 2, -4. And this point is 2.40. If this is 2.5, I'm going to say this is 2.4. So this is my first step. I plot the points I have. So I plotted 0, 12, 4/3, 2.5, 1.5, 0, 2, -4, and 2.4, 0. And now, the function is coming from positive infinity, decreasing, opening up, crossing the y-axis at this point. So something like this. Decreasing, opening up, crossing the y-axis at 0, 12. Where it changes concavity, it starts opening downward, and it reaches this other inflection point. Fine. Changes concavity, reaching the next inflection point. I'm here now. Changes concavity, crossing the x-axis at 1.5, 0. Fine. Continues to decrease, opening up till this point. Fine. I'm stretching it a little bit. It's not nice, but my units are messed up a little bit. So it reaches the relative minimum. Still opening up, but this time it starts increasing. It increases and crosses the x-axis at 2.4, 0, continues to open up, continues to increase towards infinity. This is the function 3 pages ago. Where was it? What did I do with it? Oh, 3. I changed it to X. Sorry about that. I didn't mean to, but you know what I mean. So now, yes, so you know that this is an inflection point, this is an inflection point, these are the x-intercepts, this is absolute min, and also relative, of course, min. Yes, if you want to put this in the graphing calculator, you can. We already have it. It's right here, right here. But now I know what type of viewing window I need. So the viewing window, I don't care much to the left-hand side of the y-axis. -4 is fine. I don't care to go too far out. 8 is 6 is good enough. Scale is fine. Y minimum, who cares? Not below -4, not too much. Okay, I'm going to say -6 because I graphed the function. I know everything about it. And Y maximum definitely has to go above 12 because that's where the x-intercept is. So I'm going to put 20 with a scale of 5. The ticks are there. And then I can graph. Here it comes. Done. So we analyzed this function. No one, the graphing calculator cannot tell us where the inflection point is. It doesn't tell you where 4/3, 2.5 is. You know, the calculator cannot give that. So here it is. It's coming from above, opening up, has an inflection point, changes concavity, another inflection point around here, changes concavity, reaches the minimum, crosses the x-axis in these 2 points, and goes up. So now you are empowered with a technique of graphing anything you want. However, this is what you need. Without finding everything and putting or organizing in here, looking at these pages, I will not be able to do anything. If I don't have the table and I just have this work, it's wonderful work, but it's not going to help me graph the function. So this is what I mean by everything. Any questions on this before we choose the next problem? Where is my book now? Any questions on the steps? Any questions on how we found whatever? Anything?
Professor, can I see how you put the graphing on the calculator again?
Yes, you want me to show the calculator?
Yeah.
You mean how I plot the function, you mean, or?
Yes.
Okay. And I promise to mention that now, is it good enough? Do you still need it, Dixon?
Yes, I do.
Do you need me to show anything else or just this function? How I entered it?
Yeah, how you entered it and how you gave the graph at the end.
So I put 3, and then I put x, and then the caret power, and then I put 4. Make sure you come down. Then you put.
Okay, I think I'm going. Yeah.
Then you put minus. Is that okay?
Yeah, that's fine.
Do you need me to show the window?
Mm-hmm.
Because I already graphed the function, I didn't need to see too much white out over there, left and right and below. So that's why I knew exactly what viewing window to choose for the function. And then you just click on graph.
Okay.
So do you need me to go back to this, to the window?
Oh, no, that's okay.
Do you have anything else here?
Oh, that's fine. I just wanted to see. I think that's what I was thinking.
Okay, let me know. Okay, so now I want to talk a little bit about something called the second derivative test. Yes, you can use it. Yes, I agree with it. No, I will not use it myself. I will use it just to check. Okay, so we found that the function has two critical numbers at 0 and at 1.5. At 2, sorry, at 0 and 2. So at 0 and 2, we found that the function has critical numbers. Imagine that we reach the second derivative. We have the second derivative. We study the sign of the second derivative. Now, this is an inflection point. So this critical number is basically an inflection point, which means it cannot be a max-min. If it's an inflection point, it cannot be a max-min. So the second derivative test is not applicable to it. I'm looking at the second critical number, which is 2. I know that this is a critical number. And I know that the second derivative is positive, which means the function has to look like this. What type of point 2, -4 can be? If there is a critical number, this is crucial. If this x equals 2 is a critical number and the second derivative is positive, meaning the function looks like this, what type of point can 2, -4 be?
Minimum.
Absolutely. So this is the second derivative test. What is it? Again, whenever the function has a critical number and the second derivative is positive, the critical number has to be a minimum. Whenever the function has a critical number and the second derivative is negative, then the function has to have, at that point, a relative max. So let me write this down for you. I use it to check. I will not ever not study the sign of the first derivative, because now you can plug in the sign. Once you know that this is a relative minimum, then the function, the first derivative, has to be positive and then negative. Negative and then positive. Is it true? Yes. So if you decide not to study the sign of the first derivative, you will be able to guess it from the second derivative test. I don't recommend it. Why? Why I don't use it? Because if you mess up the first derivative, then the second derivative will be messed up and you will make conclusions that are incorrect. So, in other words, that's why I covered this. Can I figure out now the sign? I don't know if I can figure it out here. But yes, I can figure it out here, left and right of this. It has to be negative and positive because this is a minimum. So I can go in and plug in. But this works only if there is a critical number. But on this side, there is no critical number that tells me anything from the second derivative. There is a critical number, but this is an inflection point. So how will I figure out? Maybe by simply looking at this as negative, so then I will continue with negative, potentially. You can think in those terms. But this is the second derivative test. So what is the second derivative test? And then we'll move on to the next problem. So